Okay, so for our experiment, we started out with copper. Copper as a solid, as you can see up here, which was a shiny reddish color. So the first thing we did in the experiment was add nitric acid, HNO3. So when this is done, at first there's like a lot of bubbling and reacting within the solution, and you can see the color green start to form from the bottom, kind of work its way up. The main thing that we first see, which I'm going to write in here, is the nitrogen dioxide, also known as NO2, and this is seen as a gas within our mix. So it's basically a brown, orangish, red kind of gas given off, very thick, and so on. And then after this, we add H2O as a liquid, of course, and this basically gives us, which is a reference to table 2.1, page 8 in the lab manual, but this gives us the copper nitrate, which is also CuNO3, and that is an aqueous solution, and basically that is it turns our solution into like a bright blue, kind of like a fluorescent blue solution from there. And after this, we add about, I believe it was 31 milliliters of sodium hydroxide, which you can see here. And when this happens, our bright blue solution turns into this dark, like royal blue, also a reference to table 2.1. Our copper hydroxide. So let's see, CuOH2, and this is seen as a solid, as a precipitate. So basically, it turns our solution into like a dark royal blue, and it becomes very cloudy and thick, and then you can see the precipitate start to form, and it's very like thick throughout. And also we can see here the sodium nitrate, kind of like a colorless solution, which is created as an aqueous solution. And then after this, we heat our solution, as you can see there, which we then see copper oxide, CuO, as a solid. So basically, it starts through black specks that are formed kind of at the bottom. They eventually mix throughout the solution though and become like a very clumpy, thick black precipitate. And we will add some hot H2O as a liquid. And when we do this, we'll actually decant the solid from the liquid. And then after that, we will add the sulfuric acid, H2SO4, seen here. And when this is done, we, as a reference to table 2.1, we create our copper sulfate, which is CuSO4, an aqueous solution. And basically through this, there's no like bubbling or anything, but you can see the color of the solution turn from like a dark brown to a green to a dark green to a light green, all the way back to this bright blue that we had from the start. There's no really bubbling or anything with that, but that's what can be seen there. And of course we have H2O over here as a liquid, the colorless liquid. And then after this, we then add, we added 1.996 grams of zinc, around 2 of course, and we stirred that and added it all at once, and this basically creates a colorless solution known as this zinc sulfate over here, which was an aqueous solution. And like I said, it was a very colorless solution. And after that, you can also see the appearance of H2 as a gas given off. And basically, once this starts to slow down, we decant the solid within that from the solution. We actually do a methanol wash as well throughout that, to give us back to our copper as a solid. And of course, course, we weighed that after it dried. And that brings me to number 2, talking about our percent yields. So basically, your percent yield, which I have written out here, is your recovered mass of the copper over your initial mass of copper times 100 to find your percent yield. So for my case, our recovered mass was 0.546 grams of copper, and then our initial mass was actually 0.503 grams of Cu, and of course when we times that by 100, you get 108.55%, which you can see is pretty high in our case. Bringing me to number 3, talking about experimental errors. So basically, things that can result for experimental errors of the percent yield being over 100 could have to do with like measuring products that contain impurities. These impurities could be causing the mass to be greater than it actually would have been if it was pure. You can relate this to like different chemicals mixing within the air and things like that. So basically creating not a perfect solid within that. And then experimental errors that result in under 100 basically could be like substances left on the stirring rod when we were stirring our solution in our precipitate, or even like when we decanted, some of the solid being mixed within the solution that was decanted off. So things like that, and that's what we did in our experiment.